All right. Welcome to chapter six. Welcome to chapter six of our audiobook, Google Cloud Identity and Access Management. So, in this chapter, we'll explore Google Cloud Identity and Access Management, a foundational service that controls access to your Google Cloud resources. Understanding IAM, Identity and Access Management, is crucial for implementing proper security controls and ensuring the right people have the right access to the right resources. Here's an overview of IAM. Authorization is a key principle of cloud computing, addressing various requirements and ensuring secure access to resources. At its core, IAM answers three fundamental questions. One, who? Which identity is requesting access? Two, what? What permissions do they have? Three, which? Which resources can they access? This who, what, which model forms the foundation of Google Cloud's authorization system. Let's break down the components of this model. So here's who. A principal is an identity that can access and request access to a resource. Google Cloud supports several types of principals. One, Google accounts. Individual users are identified by their email address, which might be a Gmail account or another domain. These accounts are often used by developers, administrators, or other human users. Two, service accounts. These are accounts for applications or virtual machine instances, not humans. They allow applications to authenticate and authorize themselves to Google Cloud services. Three, Google Groups. Collections of Google accounts and service accounts, each with a unique email address. Groups make it easier to assign up permissions to multiple users simultaneously. Four, Google Workspace accounts. Google accounts link to an organization through Google Workspace, formerly G Suite. Five, Cloud Identity domains. Similar to Google Workspace accounts, but with the Google Workspace applications. Organizations that don't use Google Workspace can use the free version of Cloud Identity with Google Cloud. Six, all authenticated users. Represented by the identifier all authenticated users. And I'll put that in the URL. Give me a second. So you can see that. All authenticated users. All right. This includes anyone authenticated with a Google account, whether it's a personal account, Google Workspace account, or Cloud Identity account. Seven, all users. Represented by the identifier all users. You see that right there? All users. Okay. This includes everyone on the internet, whether authenticated or not. So, roles and permissions, the what. Okay. In Google Cloud, permissions determine what operations are allowed on specific resources. Permissions are grouped into roles, and these roles are granted to principals. There are three types of roles. One, basic primitive roles. These include owner, editor, and viewer. They provide broad access across a project. A viewer provides read-only access to resources. An editor includes viewer permissions plus the ability to modify resources. And an owner includes editor permissions plus the ability to manage roles and permissions, as well as view those resources. While these roles make users productive quickly, they're generally not recommended for production environments as they often grant more permissions than necessary. Two, predefined roles. These are created by Google Cloud for specific purposes and for specific services. These roles provide more granular control than basic roles. They're defined at the product or service level, like BigQuery Data Viewer or Compute Network Admin, which is an owner. Three, custom roles. When predefined roles don't meet your specific requirements, you can create custom roles by selecting specific permissions. This allows for fine-grained access control based on the principle of least privilege. Resources. This is the which. Resources are the Google Cloud services and components that principals can access with the right permissions. Resources are organized hierarchically, and permissions can be applied at different levels. One, the organization level. Two, the folder level. And three, the project level. And four, the resource level. So a specific cloud bucket or compute engine instance. IAM roles and permissions. So let's dive deeper into how roles and permissions work in Google Cloud IAM. All right, so we'll go over this real quick. See the identity and organization. You can set this up here. This is the basic IAM. So you can set the permissions, the roles, where you can set roles for specific permissions, service accounts, which you can use to control certain resources like compute engine, app engine, Kubernetes engine, or more. So, predefined roles. These are created by Google Cloud for easy assignment of permissions. They typically operate at the product or service level. These are based on a predefined set of permissions. Google manages these roles, handling any changes to the included permissions as services evolve. When choosing predefined roles, follow these steps. 1. Identify the necessary permissions for the task. 2. Find the roles that contain those permissions. 3. Choose the most appropriate role, following the principle of least privilege. 4. Decide at which level of the resource hierarchy to grant the role. 5. Grant the role to the principal using conditions if needed. Let's see. See if you can get a nice image to visualize this. Yeah, and I'll add this to the chat so anyone who has the description link can see this. Okay. It's important to understand the implications of assigning a role at different levels of the resource hierarchy. For example, granting the BigQuery user role at the project level allows a principal to 1. Create new data sets in the project, 2. Read dataset metadata and list tables, 3. Run queries and other operations, 4. List and cancel jobs, and 5. Gain owner access to any jobs they create. When considering which predefined roles to assign, be mindful of the following categories of powerful permissions. 1. Resource creation and deletion. 2. Access to confidential information like encryption keys or personally identifiable information. Think social security numbers, driver's license identification, anything along those lines. 3. The ability to configure IAM policies. 4. The ability to make changes to organizational structures. And 5. Permission to change or assign IAM policies. These are more sensitive and less powerful permissions like 1. Listing resources, 2. Accessing non-sensitive data, and 3. Changing low-risk settings like VM performance parameters. Always follow the principle of least privilege by selecting the most specific roles that satisfy your requirements. Custom roles. When predefined roles don't meet your needs, you can create custom roles. These allow you to specify exactly which permissions to include, helping you implement the principle of least privilege more precisely. Before creating a custom role, consider these points. Some permissions are only available at the folder or organizational level, not at the project level. 2. Custom roles created for specific project or organizations can only be used within that project or organization. 3. You need the role administrator role to manage custom roles across your organization. The lifecycle of a custom role involves several considerations. 1. Check if existing predefined roles meet your needs before creating a custom one. 2. Permissions marked as, quote, testing or, quote, not supported cannot be included in custom roles. 3. Some permissions require specific service to be enabled. 4. Certain permissions must be combined. Certain permissions must be combined with related permissions to function properly. For example, if you want to change an IAM policy, you'll need both the get IAM policy and set IAM policies permissions for the services. So let's let's show you how to create a custom role. Okay, so in the Cloud Console, in IAM, where we already are, you click here, IAM, you go to role. All right. From here, click create role. Okay. You create the title for the role. Let's say just Jules custom role. I like a lowercase. Okay. This is the created date. You should leave that. The custom role ID. Let's say today's date, 2025, 9. And then the role launch stage. Letters, numbers, periods, and underscore. Oh, underscore. Alpha, beta, general availability. So we'll set it to alpha. This is priority. And then you can add permissions for specifics. All right. And so you have approval request, access approval, and then you can keep going over 11,000 different permissions. Right? You can keep going. All right. And add these, and then you click create to finalize the role. Here's an article I'll drop about how to create custom roles. Google's official creating and managing custom roles. And then I'll see, let's see. Um, there we go. And then you want to have this. Somebody created this dashboard that has an amazing amount of roles and permissions that are available. Okay. So you can also do this within Google Cloud on the CLI. All right. And I will open the Cloud shell. So what you can do is create a YAML file, and I'll show you. Let's Google Docs. I'll show you what a YAML file would look like for this. So for this, and you could create this in whatchamacallit, but this would be what the YAML file would look like. All right. But let's see. We'll authorize this. We can open an editor. Got it. Okay. Okay. So you create this YAML file, save this as, let's call it, you know, custom role.yaml, right? So it's programmatic. So save it as that file, and you can upload it to the Cloud Console and then enter the following. Let's confirm. Okay, you would enter this gcloud IAM roles create role ID project for this project ID, all right? And then you'd apply the custom role.yaml, all right? So delete that. You could also do it with custom command flags like this. So you have gcloud IAM roles create role ID, when the project ID, custom role title, description, and then permissions, and then the stage. This one was general assembly, right? And you would replace this with the specific unique qualities within your own. And then I'll add Google Cloud's uh, specifics for this role. Okay. Oh, already added that one. Okay. So please note, custom roles can only include permissions that are supported in this. If they're unsupported permissions, the commands will fail. So best practices of managing privilege roles and separation of duties. Managing privilege roles and ensuring separation of duties is critical for maintaining a secure and compliant environment. Here are best practices. 1, the principle of least privilege. Grant users and service accounts only the minimum privileges necessary to perform the designated tasks. 2, RBAC. This is role-based access control. Define and assign roles based on job functions and responsibilities. Identify which roles have elevated permissions and ensure they're assigned only to authorized individuals. 3, segregation of duties. Prevent conflicts of interest by separating critical functions among different individuals or teams. This ensures no single person has complete control over sensitive operations. 4, custom roles. Create custom roles when predefined roles don't meet your specific requirements, allowing for fine-grained control. 5, role hierarchy. Establish a tiered structure where higher-level roles inherit permissions from lower-level roles, creating a logical and controlled flow of permissions. 6, dual control and approval process. Implement requirements for multiple authorized individuals to review and approve critical actions or changes. 7. Regular reviews and audits. Periodically validate that assigned permissions remain necessary and appropriate, removing outdated or unnecessary access. 8. Monitoring and logging. Track privileged activities to detect unusual or unauthorized actions. Enable logging of IAM role changes and administrative activities. 9. Continuous education. Provide ongoing training for users, administrators, and stakeholders about the importance of role management and access control. By implementing these practices, organizations can effectively manage privileged roles, enforce separation of duties, and maintain a secure environment. And you can screenshot these for your convenience. Oops. All right. Policy binding. Policy binding is how you assign roles to principals, enabling them to act on resources. Bindings can exist at various levels of the resource hierarchy. At the resource level, not always available, project level, folder level, or organization level. The higher in the cloud resource hierarchy a binding is created, the broader its effect on downstream resources. Therefore, carefully consider where you define policy bindings to implement least privilege access. So, how do you assign policy bindings? Let's go to the Cloud IAM page. Okay, so here is where you could do this. At the top of this, you would select your project, right? And then add, grant access, put a new principal in here, the email address of someone you'd want to put here, john@johndoe.com, all right? In the roles section, select the appropriate role. So currently used, there's a lot already here. Let's say basic viewer, and then you can add IAM conditions for this. Let's say the keyring, add the condition type, when it expires, what type it is, and the resource. And you can keep scrolling down, and you'll see a ton of options. You'd save this, and you can also add additional, right? And or, and you can save that, but we're going to cancel, all right? And you can bind that to the role. Okay? You can also do this in the Cloud Shell with the following command. Give me a second here. So, oops. All right. Give me a second. Clear this. Oh, the following command: gcloud organizations, add IAM policy binding, and then the organization ID, and then user email, and then the role and the role name. Okay. All right. And you can replace the organization ID, replace email, you can replace role name, and be okay. Uh, Please note, when assigning custom roles, ensure you use the full resource name, such as the following: projects, project ID, roles, role ID. Okay. All right. So service accounts. All right. Let's go to service accounts. All right. So service accounts are a special type of account used by applications and workloads rather than humans. When a cloud resource or workload needs to make API calls, it uses a service account as its identity. Based on the roles assigned to the service account, the application can access various cloud resources. Key differences between service accounts and user accounts include: 1. Service accounts cannot log into the Google Cloud Console. 2. Service accounts use public-private RSA key pairs for authentication and API request signing. 3. Service accounts can be impersonated by humans or other service accounts. 4. Service accounts aren't visible in Cloud Identity as they belong to Google Cloud Managed Domain. 5. Service accounts aren't created in your Google Workspace domain. They exist within Google Cloud. So creating a service account. These can be created through the IAM portal. We're already at this. You see the IAM, go to the menu, IAM, service accounts, we'll do that. So you see it. You can also do this through the G-Cloud command line tool, REST APIs, or the client libraries. But to create a service account, the user must have the service account.admin role. And then after creating the service account, you should wait at least 60 seconds before using it. So to create it, we're already here. We would click create service account, enter the name, you know, JJ-service-account. And it'll enter a unique, let's say Kubernetes. You can enter the description, create and continue, and you can do additional options here for account access to projects and grant certain users access to this account. So this is where it comes into different types of control. You click create and continue and create done. But we're going to click cancel. We'll be okay over here. You can also do this from the Cloud Shell with the following. G-Cloud, IAM, service-accounts, create, service account name, description, you'd fill that out, display name, and you'd fill that out. If you see uppercase, that's where you'd have custom names, okay? So here we'll go into managing service accounts, all right? All right, you can disable a service account using the Cloud Console, the G-Cloud CLI, or APIs. When a service account is disabled, it can no longer access Google Cloud resources. This is a useful precaution before deletion. When deleting a service account, note that its role bindings aren't immediately removed. They're purged from the system after 60 days. Deleted service accounts don't count towards your quota. It's recommended to disable a service account before deleting it to ensure production workloads aren't impacted. If you need to recover a deleted service account, you can use the undelete command in G-Cloud, but only if, one, the service account was deleted less than 30 days ago, and two, there's no existing service account with the same name. To undelete the service account, you'll need to know its specific numeric ID. All right. Service account keys. So let's click on this. All right. Service account keys are used to authenticate a service account from outside Google Cloud. When you create a key, a public-private key pair is generated. The public key is stored in Google Cloud, and you receive the private key part of the key pair. Managing these keys properly is critical. If they fall into the wrong hands, they can be used to gain unauthorized access to your resources. For workloads running within Google Cloud, you typically don't need service account keys, with the exception of Google Kubernetes Engine. For applications running outside of Google Cloud, Google introduced Workload Identity Federation. This allows workloads to access APIs directly using short-lived access tokens. This reduces the maintenance and security risks associated with service accounts. WIF, Workload Identity Federation, is particularly useful for multi-cloud authentication, which calls Google APIs to AWS or Azure or other cloud environments, and hybrid workloads running on premises. Let me see. Okay, workload identity. You'll see that is listed here. Okay. So how do you create a service account key? All right. So ideally, you'll go to the service accounts page. Okay. Select the project. And then let's select user. Go to the keys page. Click add key. Create a new key. Choose JSON. And then create it. Click create. And you would store this downloaded key in a place where you can trust. Okay. You can also do this on the CLI with the following command. All right. G-Cloud IAM service-accounts, keys create, and you create the name of that key. The tilde and / are just to show this a path location, and the key, you can rename that. And then key.json, all right? And then for the service account, service underscore account underscore email, you would change that to what you need with this specific account. Please note, manage service account keys carefully. Regularly rotate them and avoid hard coding them into any applications. All right. So let's go a little bit into creating and managing service account keys. It's important to know that service account keys can be created through the Cloud Console, G-Cloud, CLI, APIs, or client libraries. Keys are provided in JSON or P12 format. P12 is maintained for backward compatibility. Each service account can have up to 10 keys. If you generate a 10th key, the oldest key becomes invalid. Service account keys don't automatically expire, but you can set validity periods using resource settings. A typical JSON key file contains 1, the type for a service account, 2, the project ID, 3, the private key ID, 4, the private key itself, 5, the client email, 6, the client ID, 7, authentication and token URIs, 8, the certificate URLs. Google Cloud also allows you to bring your own keys. After creating a public-private key pair outside Google Cloud, you can upload the public portion to be associated with the service account. So here's some best practices for service account keys. Securely managing service account keys is critical. Consider this. 1. Determine if you really need the service account keys at all. Consider alternatives like Workload Identity Federation. 2. Ensure service accounts created for development don't have access to production resources. 3. Implement regular key rotation, specifically in development environments, daily if possible. 4. Have developers download new keys daily, supported by an automated rotation mechanism. 5. Monitor service account key usage using the service account key list API method. 6. For local development, use client libraries and Google application credentials. 7. Prevent developers from uploading private keys to external repos. 8. Regularly scan external repos for leaked keys. Security Command Center Premium can help with this. So let's go into key rotation. So implementing a key rotation process is essential to minimize the risk of leaked or unauthorized access. Consider these steps. 1. Use a CLI tool written in Python to rotate keys running as a cron job on an admin instance. 2. Create a dedicated project for shared resources. 3. Set up a storage bucket where developers can download their new daily keys. 4. Create a group for developers who need access to these keys. 5. For enhanced security, have each developer use their own unique key. 6. Grant read access to the bucket by assigning storage.objectViewer role to your developer group. A common security issue is accidentally committing service account keys to source code repos. To prevent this, 1. Configure your CI/CD pipeline to detect keys being pushed to repos. 2. Use tools like Git secrets to check for patterns matching service account key files. 3. Implement regular scanning of external repos using sources and tools like Trufflehog, which uses Shannon entropy to detect secrets in repo history. So, service account impersonation. Service account impersonation allows other users and resources to act as a service account. This is controlled through 2 key roles. 1, the service account user. This role has the IAM.serviceAccount.actAs permission, allowing principals to access all resources that the service account can access. For example, if a user has a service account user role, they can impersonate the service account to perform operations like setting up a Cloud SQL on the service account's project. However, this role doesn't allow the principal to create short-term OAuth tokens for the service account. For that, you need the service account token creator role. 2. Okay. Service account token creator. Let's see if I can find this in the console. I don't see it. It's okay. All right, this role allows principals to impersonate service accounts to create OAuth 2.0 access tokens for authentication with Google APIs. Let's click on this. All right, and we'll go in here. Add settings. No. This role allows principals to impersonate service accounts to create OAuth 2.0 access tokens for authentication with Google APIs. It also permits signing JSON web tokens with binary blobs for authentication purposes. When granting impersonation capabilities, consider these guidelines. 1. Be careful when granting these roles to the project, folder, or organization level, as this allows a principal to act on any service account within that scope. This is not recommended. 2. Instead, grant the role a specific service account, which limits the principal to acting on that specific account only. Okay, let's go back here. I'll show you here. This is where, oh, all right, there it is. And you would add this here, manage permissions. So this has these here. Cross project service account access. In enterprise environments, service accounts are often managed in a centralized project for better governance and security monitoring. This approach is useful when you need a service account from one project to access resources in other projects, such as for automation or monitoring. Google Cloud allows service accounts to access resources across projects. By default, you can create a service account in one project and attach to a resource in another project. If you want to prevent this, you can set an organization policy with specific constraints. 1. The IAM disable cross-project service account usage. This is a constraint. I'll put this in the URL window. You can see that. All right. When not enforced, Cloud IAM adds a project lien to prevent the project from being deleted. This lien has the origin here. Oh, well, iam.googleapis.com/cross-project service accounts. And I'll add that in the chat. All right. And it should not be deleted. And there's another IAM.restrict cross-project service account lien removal. This is another constraint, and when enforced, it ensures that only principals with the following permission: resource manager.projects.update liens. Permissions at the organization level can remove the project lien. Before enabling or changing these features, thoroughly understand all dependencies and consider the implications across your enterprise. So let's go into workload identity. All right. Um, let's open that back up. All right. So Workload Identity Federation. This enables access to Google Cloud services without service account keys. It's particularly useful for applications running outside Google Cloud. So let's explore how to set up Workload Identity Federation with a third-party OIDC provider like Okta, right? So one, you're going to generate your client credentials from Okta. We don't have that on this computer, so just imagine you're doing this in your organization. There's going to be separate instructions for that, but we can get something on screen just so you can see. Okay. All right. So this would be good, decent instructions about how to do this from Okta. This is another service provider. Then within your cloud, you would enter the following to create an a workload identity pool, right? G-Cloud IAM workload identity pools create workload ID, pool 1, location, global, description, then display name, and you'll be good to go. Then you would create an OIDC provider for the pool, all right? This would be the following: G-Cloud IAM workload-identity-pools providers create-OIDC, and then Okta-provider. And then the workload identity pool would be workload ID pool 1, issuer, that's the Okta issuer URL, location, global, attribute mapping, Google subject, and allowed audience for that client ID. All right. Okay. And then you'd add an IAM policy binding for the service account. This would be good. All right, we went over that earlier. G-Cloud IAM service dash accounts, add dash IAM dash policy dash binding, and Okta project ID email for the G service account, and the roles for the workload identity user, and then the member principal for the project, and then the workload identity pool, and you'd authorize that. And then you'd verify the configuration. All right. The code like this: gcloud, IAM, gcloud, IAM, workload identity pools, providers, describe okta provider, workload identity pool equals workload ID pool for location global, right? And from here, you download the JSON credentials configuration file and use it in place of a service account key. Okay. Next, monitoring service account activity. Okay. So service accounts are a potential security risk, so monitoring their activity is essential. Google Cloud provides monitoring capabilities to view usage metrics for service accounts and their keys. These metrics allow you to track usage patterns and identify anomalies. To view metrics for service accounts, do the following. In the Google Cloud console, go to monitoring. Do here. Okay. Then you go to the Metrics Explorer. You're on the Explorer tab. All right. And then you select a metric. So let's say I am, let's say I am service account. Okay. And then active resource, say this, apply it. And then from here, let's see, no data. Service account. All right. So you can also configure the data, how to look over this. But since I haven't used this service account for some time, it's not going to show much. Oh, last hour, that's why. So let's say last 14 days. So we've had some service account activity in April. All right. For longer term analysis, you can export this to BigQuery as a cloud monitoring, retains data for a smaller amount of time. So you saw 2 weeks, right? You could probably narrow this down even or expand on this a little bit more, but you're a little bit more limited here. BigQuery is good for analyzing data over a longer period of history. So additionally, consider this for monitoring best practices. One, use Activity Analyzer to track service accounts and keys. Let's see if we can go here. Okay. Use Recommendation Hub to review and manage IAM recommendations. Let's see if we can find that. I don't see it. Oh, okay. And you can use Service Account Insights. Now, where is this? Let's see if I can find this here. Hmm. Well, Service Account Insights can help you identify accounts not used in the last 90 days. But this monitoring metrics is going to be your best bet to get some good analysis. And then you would want to use these labels, assignments here, thresholds for this, to add different metrics. Okay. When you have your filters, additional filters, sorted here. Anyways, service agents. Google automatically creates service accounts called service agents for your project when you use managed services like Security Command Center or data loss prevention. These service agents have a few things. One, they have a specific domain in their email address. Two, they're granted specific roles on a project. Three, they have roles automatically assigned when you activate the relevant API. Key considerations for service agents include: one, their roles and permissions may change at any time. Two, new service agents may be introduced for existing or new services. Three, you should not grant any principal the ability to impersonate service agents. And four, keys for service agents cannot be created. Let's see if I can find these in the get this documentation here. in some of this documentation. All right. So let's go a little bit more into IAM policy bindings. All right. So IAM policy bindings. IAM policies are attached to resources or service accounts and contain role bindings that associate one or more principals with specific roles. The structure of an IAM policy includes one, bindings that associate roles with principals, two, metadata including an E tag field for concurrency control, three, an optional version field indicating the policy schema version, and four, an optional audit config field defining how activities are logged. IAM policies have some limitations. One, each policy can have up to 1,500 principals. Two, up to 250 unique groups can be specified in a single policy. And three, IAM tracks the number of times each principal appears in role bindings. When an IAM policy is modified, the new policy typically takes effect within 60 seconds, but may take up to 7 minutes in some cases. So let's go into IAM conditions. IAM conditions allow you to provide access. IAM conditions allow you to provide access to principals only when specific requirements are met. Conditions are a part of role bindings and are evaluated at the time of the access request. A condition object has the following structure. Let me see if I can show you. It's a JSON style. All right, so see this condition and the key value pairs for title and the required title, you would fill this in. The description, optional description, expression, required expression. All right, so the expression field, and I'll expand this a little bit. All right. The expression field uses common expression language with CEL, right? And this defines logic for condition evaluation. You can use logical operators like and or. So let's see, and would be and equals this, and or equals the two verticals, and not, which would be the exclamation. And these create complex conditions with up to 12 logical operators per expression. Right? So the conditions support several types of components. One, variables. Attributes like request.time or resource.name that are populated with values at runtime. Two, operators. These are comparisons between variables and values. Three, functions. These are complex operations like string matches. Four, logical operators. These are for combining multiple conditions. For example, to restrict access to a specific time, let's try, you would enter something like this. Request time less than timestamp at July 1st before midnight. Or you could limit access to a specific service. Like resource service equals compute.googleapis.com. All right. So how would you implement IAM conditions? Okay. So you would go to the IAM page, right? Right here. And then let me see. Condition. Well, we already did this. So click this, manage permissions. Click on permissions and add a condition. All right. Manage access. So we can, let's say you add a principal. This is another way if you wanted to add a principal. And that email, john@doe.com. So here's where you'd add a condition, right? Well, you would add, this is one where you'd add a condition and add a principal. So you would click here, add a principal, add their email, john@doe.com. You could be AOL, whatever. Add the role, and then add the condition, right? And you'd add the conditions, provide the title, the description, and you could do the condition editor here, and you would click save. I showed you that a little earlier. You could also do this in the G Cloud CLI. All right. So here's an example of how you'd add this. All right. G-Cloud projects add dash IAM dash policy dash binding and the project ID, right? And then the member role for the user email, that john.doe, and then role name, and you'd change this more specifically, okay? That's fine. Okay. All right. So please note that IAM conditions allow for granular access control based on attributes like time, resource, etc. Right? So here's some policy best practices. For organizations with Google Cloud users, consider these best practices. 1, use Google Groups. Instead of managing individual user accounts, add users to groups and grant roles to the groups. 2, limit organization level permissions. Only specific teams like security and network should have access at the organization level. 3, use folders effectively. Structure folders to match your organization's operational structure, with parent and child folders having appropriate access grants. 4, grant project level permissions. When a principal needs access to only some projects in a folder, grant access at the project level rather than at the folder level. 5, use IAM conditions. For more granular control, use conditions to limit access based on criteria like time or location. 6, regularly review policies. Conduct audits to identify excessive or unnecessary permissions. 7, implement monitoring. Enable logging to detect suspicious behavior. 8, educate users. Provide training on IAM policies and security best practices. With policy intelligence, you have another factor. Google Cloud provides policy intelligence features to help you manage permissions more effectively in the following ways. With 1, IAM Recommender. This uses AI to suggest removing excessive permissions based on usage patterns. Let's see if I can find a nice article on this. All right. This will be a good article on this one. 2, Policy Analyzer. This will identify potential security threats by scanning IAM policies for issues. Policy Troubleshooter. This helps diagnose access issues by comparing resource permissions to principal permissions. These tools analyze access patterns and provide recommendations to align permissions with the principle of least privilege, reducing your attack surface and enhancing security. Tag-based access control. So tags are key value pairs that can be attached to organizations, folders, and projects. Unlike labels or network tags, IAM tags follow an inheritance model. Tags applied at the organization level are inherited by child objects, though this inheritance can be overwritten. So let's see if I can find a nice article on this for you. That might be it. Access control. This will be one good article. This is on Cloud SQL, so it'll be a good use case, and this will be a good general information on this. All right. So the structure of tags includes a key value pair, a permanent globally unique ID, a short name for each key and value, and a namespace name that adds an organization ID to the short name. All right. So this will give you some ideas of what that looks like. All right. So best practices for tags include establishing a consistent tagging strategy, aligning tag structure with your resource hierarchy, using descriptive tags, implementing tags for security and compliance needs, identifying resource owners through tags, automating tag application, conducting regular tag reviews, using tags for IAM policies, monitoring tag usage, and then educating teams about tagging best practices. So Google Cloud, let's go into their ACLs, access control list, and uniform bucket level access. All right. Google Cloud Storage provides 2 approaches to access control. 1, uniform bucket level access. This uses IAM for consistent permissions across all objects in a bucket. This is the recommended approach for most cases. And then 2, legacy fine-grained ACLs, right? So this provides separate access control at the object level. And let me get, okay, let's go over here. All right. So when using ACLs, you can define permissions like read, write, or owner, and scopes like who can perform actions. And each bucket or object can have up to 100 ACL entries. Let's go create the bucket. You'll see it here. Uniform versus fine grain. Okay. So best practices for cloud storage access include one, avoid sensitive information in bucket names. Following the principle of least privilege is key. Do not grant owner permissions broadly. Be cautious with anonymous user access. Avoid inaccessible objects. And then delegate administrative control carefully. Uniform bucket level access simplifies permissions management. This helps by disabling object level ACLs and controlling access solely through IAM. This approach supports features like domain restricted sharing and IAM conditions. So consider using uniform bucket level access when you want to streamline access management and you need to use IAM conditions or domain restricted sharing. Use fine grained ACLs when you want uploaders to have different control levels than others, and you need to use XML API to view or set permissions. So no, once uniform bucket level access has been enabled for 90 days, it cannot be disabled. So I am logging and monitoring. Let's go back into that a little bit. All right. All right. So Google Cloud writes audit logs to help answer the critical question, who did what, where, and when? These logs include admin activity logs and data access logs. IAM audit logs use resources like API, audited resource, IAM role, and service account. These help to record different types of activities. So log names follow a pattern based on the resource scope, like the project, the folder, the billing account, or the organization, and the log type. Service account activities that logged include creating the service accounts, granting roles to service accounts, setting up resources to use service accounts, creating and using service account keys, authenticating with service account credentials, and then impersonating service accounts. These logs are essential for security monitoring, compliance, and for forensic analysis. Identity and access management forms the foundation of your Google Cloud strategy. By implementing these principles and best practices, you can ensure that the right people have the right access to the right resources at the right time while maintaining a strong security process. So I'll show you real quick what it looks like in the console. All right. So from here, and we showed you this early, find the resource type, and then you type IAM, the service account, authentication events, apply. We've just done this, right? And then you add additional filters. You can aggregate this, right? You can add an additional filter and then visualize these resources as you see here. All right. Please remember, regularly monitoring IAM activities helps in detecting unauthorized access and ensures compliance. By following these steps, you can effectively manage IAM resources in Google Cloud, ensuring secure and controlled access to your cloud resources. Thank you for joining me on this one. I hope you enjoyed this. The next chapter will be on the virtual private cloud, the VPC. Thank you.